Hello, everybody. Welcome back. Today, we are going to be starting what I think is probably my favorite part of the biological unit, and we're going to be actually focusing in on the parts of the brain. So, today, we're focusing, just like we did yesterday, on understanding the functions of these parts. So, with the neurotransmitters, we focused on the functions and what happens if there's too much or too little. With the brain parts, we're focusing on the functions and then what happens if they're damaged and how, when we see that a brain part's damaged, that could potentially, inform us as to what that brain part actually does in terms of its function, right? Because if we see that a brain part's damaged and that's fundamentally changing your behavior, then clearly, that brain part is likely playing a role in that type of behavior. So let's get on to it. So we're going to break it down in terms of the three kind of large regions of the brain and then the brain parts that fall within those regions. So the first, or to give some context, actually, um, when I'm talking about the three regions of the brain, we're looking at it from oldest to newest. So kind of the most primitive to now the most advanced and high functioning, more developed parts of our brain that through evolution have become more advanced. So kind of the ones we use for higher level thinking that make us fundamentally human. So, going from old to new, the oldest part of our brain starts at the brainstem and the cerebellum, because those correspond with the most basic functions of like breathing, heart rate, and movement. Then we get into more of our specific sensations in the limbic system, things like fear, memory, etc. So, a little more advanced. Then we get up here to the cortex, which I remember my cortex is most complex. So cortex is our most, I guess, recently um, developed part of our brain and is where we have our lobes. And we see things like the frontal cortex corresponds mainly to our higher level thinking capabilities in terms of reasoning, judgment, planning, all that good stuff. So that's your kind of brief overview of those three regions we're covering, and then we're going to go in depth into the parts of the brains that fall within those regions. So we're going to go from oldest to newest, or least advanced or most basic to most advanced and higher level thinking. So let's get started with the brainstem and the cerebellum section of our brain. So we're going to look here, we're going to look at the pons, the medulla, reticular formation, and the cerebellum. So let's get into those functions. So first, we have the medulla. The medulla is responsible for breathing and regulating our heart rate. So again, we see that these things in the brainstem and cerebellum are really essential and basic to our core functioning. I remember the medulla is responsible for breathing and heart rate because I think of medulla Medusa. And if you know like the old Greek myth, she has like the snakes for hair. So I just think I'm like, oh, if she poisons you, you're like, your heart's gonna stop. Or if her snakes choke you, right, your breathing's gonna, you're not gonna be able to breathe. Medulla Medusa. Okay, then pons. This is, we'll see here. The pons acts as the bridge to the cerebellum. So it's also responsible for sleep. So it helps us in our sleep cycles and whatnot. Because the pons is responsible for sleep, I remember it as pillow pons. Okay. Next up, we've got the reticular formation. And this one is responsible for keeping us alert, awake, and aroused. Particularly if we have this one damaged, you're going to see that you might end up in a coma because obviously you're not awake and conscious and all that good stuff. So reticular formation, the way I remember these things are by saying retic tick 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 formation, like a clock that is ticking, right? The alarm clock is keeping you awake, alert, aroused. Retic tick 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 formation. It keeps you ticking and moving. Finally, we have the cerebellum, which is these three are part of the brainstem, really. Cerebellum we see is kind of attached. It's its own what they call like the hindbrain or the little brain here. So cerebellum is all about movement. So it aids in movement, coordination, and balance. So A funny way I remember that is by thinking cerebellum, cerebellum, like she's playing basketball or something. I picture, get those visual images in there, right? I picture a girl who's playing basketball. To play basketball, right, you got to be coordinated. You have to have balance. You're not going to be falling over. And it's just helping us, with our everyday movements of walking or even just fine motor movements like typing on a keyboard or something, right? Then we've got our thalamus. So this is kind of off in its own world. I don't think it's on the picture here. Let me see. That's okay. They don't have good pictures of it. Whatever. Thalamus, again, not necessarily in either of these parts, but is kind of up here more. So, thalamus is a good one to know, and I think people struggle with this one. Thalamus is like your sensory hub. So, it's where when you're taking in all of your senses, whether it is visual, auditory, touch, whatever you have, all your senses that are going into your brain to be processed take a pit stop in the thalamus. So how I remember that is if you've seen Elf, the movie, um, there's that part where he works in the mailroom and there's all those tubes where they have to stick the mail up into the tubes and then it goes to the correct floor or the correct department or whatever that it needs to go to. So you think of the mailroom like mail from all over the world's getting in the mailroom. Then their job is to sort it out, figure out the correct location it goes to, and then put it up those tubes and send it on its way. The thalamus is what I kind of correlate to that. So the thalamus again is taking in all your sensations, visual, touch, hearing, etc., and they're all coming in everywhere, all a mess. And the thalamus's job is to organize them and then send them to the correct part of the brain, aka the lobe in the cortex. We're going to talk about those at the end, but send them to the correct lobe for final processing. So the thalamus isn't responsible for just one type of sensation. It's not where they're actually being like processed. It's more just organized, sorted, and then sent to their final destination for processing. Um, I will put in here that it processes everything except smell. That's really important to note. For some reason, smell just goes straight to the olfactory bulb and doesn't take a pit stop in the thalamus. All other senses do go to the thalamus. So now we're going to move on to the second region of the brain. So we're getting a little more advanced and complex as we go on. And we're going to look at the limbic system. Has to do a lot with like emotions and memory and things. So within the limbic system, we've got hippocampus, hypothalamus, and amygdala. And you can see these located here. So let's get to it. Hippocampus is connected to memory. It does not store memories. Memories are not like, this is not where the filing cabinet of memories are, but it helps process our memories when we're actually forming them and getting them ready to put into storage. Hippocampus is very important though, because if you damage that, you're going to see that there's major problems in terms of like memory loss or formation and being able to like create new memories, etc. A way I remember hippocampus as memory is if you saw a hippo on East Campus, you would never forget it. So there you have it. You can make that nice little visual of a hippo walking around East Campus, and I think you'll always remember that. Okay, next we've got the hypothalamus. Now, I've talked about multiple times in this course how the body likes to maintain balance and always be at homeostasis. And this is what the hypothalamus's job is to do. I think of it as kind of the thermostat or thermometer of the body because it monitors a bunch of our levels in terms of like hunger, temperature, even things like sexual arousal. It monitors all our levels and needs in terms of that. And if it sees that something's out of whack or imbalanced, it's going to talk to its neighbor, the pituitary gland, which is the head honcho of the endocrine system. So you'll see this here, right? Pituitary glands here. We're seeing amygdala, hypothalamus, right? These are all next door to the pituitary gland. So what it does is if it sees that, oh, you're thirsty, we're hungry, or right, we're cold, whatever it is, it's going to send a little message to the pituitary gland in the endocrine system and say, hey, we got to produce some hormones to get us back to where we need to be and balance out our body and go back to homeostasis. So again, hypothalamus is just, I think, kind of your thermometer, making sure that everything's good. I remember when I worked at Culver's, I had one of the jobs you had to do was temps, and that in the morning, in the evening, and at lunch, you had to go around all the different food items, stick a thermometer in it, and write down the temperature. And if it was too hot, you had to turn it down. If it was too cold, you had to turn it up. Right, and that's essentially what the hypothalamus here is doing. It's the endocrine system that kind of allows you to turn it up or turn it down. All right, then we've got the amygdala. This one I think is probably the easiest one for people to remember because a lot of people think of it as angry Amy. So we see amygdalas over here. It's responsible for fear, anger, and aggression. So all of those feelings. So amygdala, very, very important in processing because we say that if we don't experience fear, like our amygdala is damaged, you're not going to feel fear. And that's problematic. Just like I said, if we don't feel pain, it's problematic for our safety. But if we don't feel fear, right, we're going to get in really dangerous situations and, have, our safety be put at risk. So amygdala, angry Amy, fear, anger, aggression, processing those things. All right. So now we've made it to kind of that third region of the brain we're going to focus on. And this is the most evolved, most adapted, most high level, kind of what makes us uniquely human, right? We see that animals probably have these things in their brains, but as far as like us being humans, this is kind of what differentiates us from everybody else. So cortex contains the 4 lobes that we need to know in the brain. I remember cortex is complex, right? It helps us with complex thinking. Cortex, complex. So within that, like I said, are the 4 lobes. So when it comes to the lobes, the 4 lobes here, most of them correspond to some kind of sensory function or motor function in processing like sight, a sound, whatever. Association areas are the parts of the cortex that don't do these things and instead help out with higher level thinking and language. So things like reasoning, impulse control, whatever. And then language in terms of examples of these are the Broca's and Wernicke's area. So these are mainly in the frontal lobe, we'll see. So let's get on to it. So we're going to focus on these 4 lobes that I mentioned and what they do. Frontal lobe, I said, is our very important one in terms of like higher level thinking and processing. And again, what's making us uniquely human. So frontal lobe, higher level thinking, helps in judgment, decision making, reasoning, speech and language, and also some movement. And again, we're going to look at things that are contained within each of these lobes, and we'll see again that's why these make sense. So prefrontal cortex is the part of the brain that I said does not develop in us until we're older. So y'all are still probably developing your prefrontal cortexes, and that's why you can sometimes make an excuse to your parents that you might be making some little risky or reckless decisions because you're still developing your prefrontal cortex and it's responsible for decision-making, judgment, reasoning, and impulse control. So we see that's why high schoolers maybe, from a biological perspective, make those poor choices sometimes. But we said frontal lobe also plays a role in language, and that's because the Broca's area is contained in it. Broca's area, we're going to compare Broca's and Wernicke's are 2 really good ones to know. Broca's area is the part of the brain that allows for us to move the muscles in our mouth as we talk in order to produce speech. So very, very important. If we have the Broca's area damaged, we're not going to be able to get words out of our mouth. We might be able to think of them and like understand language in our mind, but we're not going to be able to like move our muscles necessary to actually talk. So yeah, you can think Broca area, broken speech. Because if your Broca's area is broken, your speech will be broken. You cannot talk because your muscles can't move properly. And then we've got our motor cortex. right? And just like we said with motor neurons, that motor means movement. So motor's cortex is helping us out with those voluntary movements. So again, that's why we see all these things contribute to the overall frontal lobe function. Okay, then we've got parietal lobe. I remember this is like the triple T threat. Parietal lobe helps in touch, temperature, and taste sensations, and also like visuospatial relationships. So kind of like understanding like where you are in relation to like the items that are around you and stuff. Okay. Um, so within parietal lobe, we have the somatosensory cortex, and that is responsible for processing touch and movement. And again, right, we see touch and also that kind of bodily spatial awareness of like where we are in time and place and all that. So somatosensory cortex, touch and movement. Easy one to remember, occipital lobe is mainly responsible for processing visual information. So just like I said, information from all of our senses, except smell, goes into our thalamus to get processed and sorted out. And if it's a visual information, right, it's going to get processed or get sorted out in the thalamus and then sent up in your little tube to the occipital lobe for the final processing because it's visual information. And within this is the visual cortex. That's where it's all processed. Okay. Easy way to remember this, I said, is occipital lobe. You can think open your eyes or like optical illusion, right? Optical illusion, open your eyes. I also forgot to say that for parietal lobe, another way I remember it, in addition to the triple T threat, is like parietal pool. Like I think if you're jumping into a cold pool, you'd be activating your parietal lobes because you're going to touch the water and you're going to have that temperature sensation too of like, oh, this is real cold. Okay, finally, we've got our temporal lobes. So this processes auditory information and also aids in language comprehension. So, way I remember temporal lobes as being auditory information, I think your temples are here, and that's real close to your ear. All right, temples here, ear here. So it's processing the things you're hearing, your auditory information. Within temporal lobes is the Wernicke's area. So I said we're contrasting Broca's and Wernicke's. Wernicke's area aids in our language comprehension, meaning that if we have damage to our Wernicke's area, we are not able to understand language. Like people can talk to us and we wouldn't know what they're saying. We aren't able to process and think about language in our minds because we have trouble understanding it. Right. So I put some like gibberish here. Because someone with Wernicke's area could just speak and it would be gibberish and it'd be really jumbled and it wouldn't make sense. But someone with Broca's area could understand language and what people are telling them. They just can't get it out of their mouth because they can't move the muscles. So Wernicke's area, you just don't understand language. You aren't able to mentally put things together to like put together words to say. So you could move your mouth and say gibberish or really jumbled up sentences and stuff. But again, you're not able to comprehend it and make understandable sentences or understand what people are telling you. Okay, final thing. If you look at the brain from the top, we see that, yes, we have the four lobes here, but looking at it from the top, it's kind of divided overarchingly into two hemispheres. And y'all hear all this stuff about right side of the brain, left side of the brain. Tomorrow we're going to debunk that. Most of that stuff is kind of just like pop culture and not really accurate. But we do truly have two hemispheres of the brain, and they are connected by something called the corpus callosum, which is a really important term to know. Corpus callosum is a bundle of nerves that just connects those two hemispheres and allows for that communication, instantaneous communication between those two hemispheres. A way to remember that is you can say corpus call someone, right? Because it's communicating between the two hemispheres. Corpus call someone. And you can think of like an old school phone where it has like the little like rolled up cords. You guys probably don't even know what that is. But the old school home phones where it was like cords and stuff. Yeah, you can think of like that kind of in between the brain. So, main advice is to come up with as many of those mnemonic devices as possible to help you remember the functions because there's a lot of parts and it can get tricky. So, coming up with those mnemonic devices of like corpus, call someone, and visualizing like the little phone cord between the two hemispheres, or like angry Amy, the amygdala has to do with anger. Hippocampus, you'd never forget a hippo on East Campus, and like visualizing that, right? That's going to create a strong memory. So there you have it. Have a nice rest.